So we can start the panel discussion with the first question from the audience. Yeah.
Hello. Oh, thanks for the great talks and all the great things that happened throughout the day. I think I brought this up at multiple times. I certainly talked to Chris about it. So there is this trend that we are developing this diagnostic data set um, that measure things that completely open-ended data set may not measure. But that brings us to another problem, right? So something like GQA and the whole presentation about language of thought, that doesn't get us to say, if you remember the poster child for VQA, what is the mustache made of? That's sort of the charms. One of the charms is that it can be really out there in terms of how open VQA can be. So now we're doing this more constrained setups. Uh, is it the agreement of the panel that it is too early to try to tackle problems like what is the mustache made of, or should it go in like parallel directions? Should we work on both? Or, I just want to open a discussion on that topic a little bit.
Okay, I think that's kind of a hard question. I guess the first thing that comes to mind is that oh, is it not? Can you hear me? Okay, good. All right. What? Oh, okay. All right. Yeah, I like the first thing that comes to mind when I think about that is, like, personally, I feel like it's really good that we have these diagnostic data sets because at the end of the day, I don't think anybody necessarily wants to solve VQA, the data set. We want to solve VQA, the problem. And if we're going to deploy our systems, it's important that we understand them. But as you said, there is this kind of issue that we've created. Now maybe the data sets we're looking at are a little bit too constrained. So I guess my answer would be it's really important to be thinking about both of these things. And you can have some people that are thinking about the constrained setting and some people that are thinking about the more wacky setting, or maybe not wacky, but some of the wacky questions, the original setting at the same time, and hopefully eventually we can converge. That would be my response.
So I think it's good to have. Is this working? Okay. I think it's good to have both, and I think, and one thing maybe I should have let Chris talk about it, but there is in NLP we have the universal dependency. So when we run on parsing, we report how many languages? Many languages, and and all these languages, and we usually good new parsers, they don't get like state of the art on all the languages. They are better than the others on this group of languages, slightly worse on the others. And you can really think like taking all these data sets, kind of like that are working on somewhat related problems, like VQA, GQA, NLVR, all these things, and they all test and emphasize different things, and just create this giant table and test on all of them. And this might be giving you a much better and complete view of your model.
Yeah, so I think it's a great question, and you know, how to find a good question is, I can easily argue for both sides of it. On the one hand, a lot of sort of my history and belief system is to say that artificial tasks are awful. So I'm kind of the old guy on this panel, I guess. The history of natural language processing that essentially back in the 60s and 70s and early 80s even, right, everyone worked with teeny collections of artificially generated sentences. And so when empirical and statistical methods sort of hit NLP in the late 80s, and which is sort of the period when I began, I mean, essentially the sort of the core belief was that the only thing that was useful to do was to build systems that actually operated over unconstrained real language, and it was a complete waste of time, these sort of artificial curated data sets that people have spent the last 25 years on. And quite a lot of me still thinks that. I mean, so, I've worked a lot on the variously known as recognizing textual entailment natural language inference task in NLP,
Hello.
I'm the smart one of the panel. Yeah, I think, a few years ago when the neural net started working, we just, I'm definitely at fault of this, just complicated problem and let this black box solve it for you, right? We did this data set called movie QA, right? It's just a movie and a question and just learn whatever knowledge you need from this, right? And obviously then, you get a bit of humble pie and then you learn that this is way too much because there's so much external knowledge that we are using to actually reason on that level. And then you go and you break down to more contrived, like what we think are more contrived cases, which I think we need to solve before we go to that. So I'm not sure whether we are ready for the mustache case yet because there's so much more knowledge to be kind of taken in those open-ended questions. Maybe there's a way to really have multiple tasks or even grounded learning. Like there needs to be more knowledge than just like this closed data set that we're using and hoping it's gonna magically learn stuff.
I have a little follow-up on something you have said. So, like you said, NLP has this like big table with multiple tasks or at least multiple languages, but it is very lacking in vision and language. They do even something as closely related as, say, VQA standard and VQA changing priors. How many papers do you see published on VQA changing priors? How can we promote more papers to sort of start doing both? Maybe do the diagnostic data sets as well as the open-ended one, or some kind of decathlon where you are doing more than one task. I think it is like pretty, some paper only do clever, some only do VQA. I think NLP does it much better than vision and language in that regard. How can we, start forcing, or I don't want to force people, but
yeah, I'll be careful with any argument that says NLP does something better because we will find counter examples very fast. But I think you kind of like answered yourself to a certain extent. So you mentioned the decathlon, and now there are a number of benchmarks in NLP like glue and super glue, and I guess next year there will be mega glue. But these things, they basically push for like you evaluate on all these tasks, you get some kind of aggregate score, and you do a challenge. And these things have some kind of, these things do have psychological impact at pushing the community to a certain degree. They're not bulletproof, but it's a step. It's hard to change how a community thinks about evaluation. I think even in NLP, and Chris probably understands better knows it better than me because I'm not a parsing guy. It took a long time before people started like evaluating on all these different things and kind of like stepped beyond the pen treatment, right?
Yeah, I mean, so clearly it just depends on community beliefs, right? If the community believes something is important, then it'll start happening. I mean, obviously the most direct manifestation of that for many of us is people act as reviewers, and if you just reject papers saying this is only evaluated on one task, and enough people feel that way, that forces community change pretty directly. And I mean, that's kind of what did happen in dependency parsing, right? In constituency parsing, by and large, everyone just evaluated on English, but in dependency parsing, sort of through a combination of availability of data and the attitudes of the people involved, it just sort of became the community norm that we're not going to accept this unless you're showing results in at least 10 languages.
I don't really have anything to add.
Okay, so I guess we will move to.
Yeah.
well, thank you for the great discussion.
Thank you. Where do you think we are with the data sets? Like, do they currently suffice? So I submitted the paper like in 2016. The area chair said, VQA, we got enough data sets, we're done. We've seen so many more since then, and there still seems like there's gaps. What do you think is like, what's missing right now before we say, I guess, I don't want to say it's solved, but like what's missing right now before we feel a little better about it all? I mean, we have text now. We have all these things. Like, what's really what would make us feel better that algorithms are right for the right reasons and not right for the wrong reasons, and are really doing stuff?
I don't know, because all these data sets are created as proxies of what we think it's important to function in the real world. And it's very hard to build a replica of the real world in simulation where you could actually, like, these tasks would naturally emerge as part of the more complicated setup. So it's hard to have like one data set to serve it all, right? I recently started working on simulation, so this is really where I think it should be going. And these guys here have worked on navigation and basically building these simulated environments where you're kind of forced to start interacting with things, maybe asking questions about things. Imagine there's people in these environments. You're forced to ask, to communicate with these other participants to achieve your goal. So it kind of emerges as part of the real world. Now that's also very hard to create, right? So I think we're still at the level where we need to create these data sets with maybe multiple tasks, but they're kind of proxies for what we really want in the end.
Actually, I just wanted to add, in terms of data sets, there was one paper, I forgot who wrote it, but they thought about VQA and they thought, that could be helpful for the visually impaired, right? And so they did a study where they actually showed that people suffering from visual impairment asked questions in a very, very different manner than the ones that we have in our data sets that we use for developing our models. So there's also a big gap to breach between the data sets that we build for research and the data sets that we can actually use and that could be useful for people who would benefit from this technology. So there's also work to be done there, I think.
Hi. So yesterday I was in the computer vision after 5 years workshop, and Alyosha talked about 5 or 4 regrets, future regrets that he doesn't want people to work on. One is language and vision. So one of those future regrets is vision and language. So, but I'm a vision and language person, so I don't agree with him. But I think I'm wondering, what's your opinions like?
I'm always full of regret, so I don't think it will change it. We should have invited Alyosha, obviously. It would have been interesting. As the most senior person?
I think vision and language is a great task, and I do. I mean, it's the simplest task where there is lots of useful stuff to be done in a multimodal manner, or if you just view it from a language-centric point of view in which you have grounding and that you could work with grounding. I mean, that doesn't mean, it's not everything. I mean, there's certainly reasons for why you think you might want to work with video, because once you get into sort of activities and things like that, if you only have an image, you have to do a lot of inferencing of what the activity is based on one frame, whereas if there's actual video, you can see the activity. So, for some things, video is better, and, it's also important to remember for language that there's lots of language that doesn't have any visual grounding, right? People are very fond of talking about embodiment and grounding, but we spend a lot of time talking about our hopes and fears and arguing over different political ideologies and things like that, and none of that has groundings in the real world, right? So there is also just this abstract world of ideas.
I feel like it's on, right? Yeah. Okay, yeah. I feel like I should say something since I'm from Berkeley and Alyosha is also from Berkeley, and I feel like I should. But yeah, I mean, I also think that language and vision is a really important problem to work on, and I think, at least for me, the reason why I like working in language and vision is that, to me, a really key component of building AI systems that are actually going to be able to help us is building AI systems that we can communicate with and that can communicate with us. And there are different ways that AI systems can communicate with a human, but I think that it's pretty hard to argue that language is a really important part of that process. That's an easy way for humans to communicate. It seems very natural that we would want to communicate with our AI systems. So at least for me, that's why I think it's an important area of research.
So I think in general, you're going to get vision and language and because because it seems like walls are collapsing. You know, robotics and is also kind of like also now brought into the game. You see it in publications, you see it in collaborations, you see it in how people jump between venues, you see it in how people are hired in departments. So it seems like in general, kind of like all these distinctions are going to become much softer along time. So I don't know if we'll have regrets about it. It's like, I'm not a prophet, but it's it's not going to be only language and vision. So it's not only the language people that are bad. It's also the roboticists.
Yeah, thanks to all of you. It's very excited to see so many people from the communities of NLP and computer vision. So my question is, in the for VQA or Visual Dialog, so do you think which one plays a more important role? Computer vision or natural language processing? And and my second question is I think the people who do not suggest to do vision plus language, because I think the main problem probably the metrics in this field, especially the captioning or some other tasks. So what do you think about the metrics or what is the problem of the current task for the current task? So thanks.
I mean, I'm scared of metrics, so I don't know. I personally think evaluating generation is extremely difficult. I don't really have a good idea on how to do it, so we are just not working on generation. So I'm a bit of a coward. So that's what NLVR, for example, is like very straightforward binary thing. That was something that was very important for us. Keep it simple. But generation, I mean, you're just seeing one projection of like the entire generation problem. There's many other generation problems, like summarization, simplification, machine translation even. Machine translation will maybe, okay, I don't know how, but in many other things, dialogue, it's like, even without vision, it's just very difficult. So generation is a very challenging evaluation problem.
Okay. Yeah, what I like about visual dialogue is that the metric is the success of the dialogue. So that's something that's easier to measure, because you can have your model talk to a human and give the human a task, like make the model guess this object, and then you just let the two speak together, and then you just see at the end, did you guess the right object or not? So that's in dialogue in general, this is kind of the metric we go for, the task completion. It's costly to evaluate because you need to talk to humans to get the dialogues and then to have the evaluation. But it's kind of the most reliable one that we have, because in generation in general, you'll see people moving away from the automated metrics like blue and rouge, etc., and go towards human evaluation. But the problem here is that everybody does it differently. Some people will just ask for one score out of 1 to 5. Others will ask for different ratings of appropriateness, inference, and just different aspects of the evaluation. So there's not a real standard in human evaluation either for natural language generation. So that's why I kind of like just going for task success. Was the dialogue successful or not? This is just clearer to evaluate, I think. And for the first question, well, working on visual dialogue, I can say that it's really hard to do both very well, the computer vision part and the language part, but they're complementary. You can't just do really well at one and poorly at the other, and then have a system that can do visual dialogue properly. You really need to work on both, and then you need to work on how to fuse them together, the two modalities, into one model, so that your model can read dialogue history, look at the image, and then give a sentence that makes sense. So there's a lot of work to do in both areas. Yeah.
I just wanted to add that I think as problems become more interesting and more important, I feel like they will also become harder to evaluate. Like you think about, dialogue system is really hard to evaluate, harder to evaluate than classification. And I feel like it's not good to think that if something is hard to evaluate, it's a bad problem to tackle. It just means that maybe you need to be a little bit more careful and think things through. So I just wanted to mention that.
Hello. Recently, we see common sense reasoning in NLP community becomes an emerging topic. And we also see some initial effort for building a VCIR data set in the vision community. So my question is, how do you see the role of common sense reasoning in the field of vision and the language? And what's your initial thought on how we can incorporate common sense into this field, or some existing method? Thank you.
So I think work on common sense. Hello. So I think work on common sense and in general making use of knowledge and reasoning to understand things, it's a great area. It's been neglected for decades, and it's marvelous to see more of it. So all power to it. I think in the first instance, it's easier to see the need in language than vision, because language is always a abstracted summary, and that there's lots of detail to fill in, and that common sense knowledge is useful. Whereas for something like the current VQA data set, it's not really clear that common sense would do much good there, frankly. I think it clearly can be used also in vision problems, but it then has to be vision problems that are sort of much more contentful sort of activities in the world, where there's something that you can use common sense knowledge to understand the implications of what's seen in the world. And various vision profs show talks where they show slides that show good examples of these high-level reasoning from vision. But I think there isn't really kind of a collection of data and a task that really exploits that at the moment. But I haven't looked closely at VCR, and maybe that'll be the cool solution.
Yeah, I think common sense reasoning is actually very important. If you look at some of those captioning results, they violate common sense quite a lot of times, right? I would say it's a toilet on top of a toilet, or some things that can never happen, and this is just not captured in those blue or rouge or whatever metrics people are using. And I think people should do something about, some sort of a incorporation of knowledge basis, or some knowledge. Now, there was the extreme case, I think it was called Psych, or what was that? Someone building for 30 years a knowledge base. Maybe we should at least see whether that can be useful. And then if it's... but I think there should be more efficient ways of getting that common sense. For example, if I generate, there's a toilet on top of a toilet, any feedback I should receive is this is a rule that it's not possible in the world. Right? Maybe there's even a generalization of this rule. Maybe some objects can never be on top of another object, and now this should somehow become part of my common sense, which I should be building as I'm going around and talking about things. So maybe I should be more active way of creating these knowledge bases that are actually useful for the current tasks of machines. But I absolutely think that we need to have some of those rules embedded in these neural networks, which currently are not there.
So this isn't maybe a direct answer to your question, but something that I think about when I think about common sense is we also need to be careful where we're drawing our knowledge of common sense. So I've thought a little bit about bias in image captioning, for example. And if you build a system that tries to mine common sense by looking at a lot of real world data, you might want to be careful that you're mining, good common sense and not, bad biases that your, unsupervised mining model might think is good common sense. So that makes sense. Just a thing to think about.
Use one rule.
Yeah. When I went to school, the teacher would just tell me a rule, right? Don't cross the red light, and that was it. I don't need 100 examples of red lights and me being hit by a car, right? So there should be a way to use that.
Do you never cross red lights?
I do.
It's a complicated goal. Having been hit by a car.
I know how to avoid to be hit by cars.
Okay, so I have a question. It seems to be a bit ironic that the poster child of why we do VQA is to help blind people to understand the world, and yet last year we had the VizWiz coming back to the discussion that kind of started but didn't, and it looks like there is very little traction on that, right? There is like 5 submissions on the leaderboard, and I didn't hear anything today about it. So I'm just curious if you have a sense of why that is. And that includes maybe the VQA organizers.
I think it's crazy hard. Like
is it just because we don't work on it because it's hard?
I don't know. I completely agree with everything you said.
Okay.
I just think it's insanely difficult.
Yeah, I agree. I don't really have a good explanation for why.
I actually disagree with both things you said. So the first thing that you said was that the poster child was visually impaired users. It's actually missing the second point, that there were 2 motivating cases. One was that there's applications that need them, which is not just visually impaired users. Even for sighted users, there may be applications that you could help them with when they're not paying attention or they can't see the image. And the other is just as a test of intelligence, which isn't actually tied to any particular application. And that's what perhaps the community has been pushing on more. But I think the bigger point behind the thing was that, yes, while the data set, VizViz, perhaps isn't here but has its own challenge, I think a lot of the things that it taught us are being represented here. If you think about certain aspects of that problem, that people tend to ask about brands and text written in images. Well, there's a text VQA dataset and a competition. People ask about images that are not well framed, and so you need to tell them. There's not actually a competition on that yet, but that I think so. What it does is that you come close to a real application, you take inspiration, and you run away. And then you basically create little modules of tasks that you can solve.
So it seems like this VQA kind of encompasses a lot of different skills going on, right? You want to count the vultures that was in someone's talk earlier. I have to know what a vulture is. I have to know how to count. What do you see how do you see the potential for learning these tasks independently and applying them later? Or doing some kind of curriculum learning or something where we're building up these skills in pieces rather than just having one big data set that encompasses everything that we want to do?
Yeah, I mean, I don't think this task should be done independently, right? Because the knowledge you learn from one task can be reused in another task. So why should you learn somehow in an unsupervised way that knowledge in a new task, right? So I don't see any point in that. So I think there should be some sort of curriculum learning of tasks, and it should be done in some sort of compositional way where a new task can exploit other knowledge from other tasks. So yeah, I think that should be what people should do.
I sort of agree with that, but clearly there is some specialization, right? I mean, and counting is in some sense, the poster child that, even for humans, counting is a specialist skill that we pass on to little children. And it sort of seems like in the same way, the sort of basic object recognition, texture recognition, properties, stuff that is the main content of vision systems doesn't for free give you counting, and so it is sort of a specialist skill you have to add on. And so it sort of makes sense to the extent that there are such things. Maybe you want an integrated system, but it does make sense to focus on some of those missing specialist skills and work out how to augment models so they cover them.
I just wanted to go back to the question of common sense. So I just wanted to ask, how do you define common sense? Do you think there's a data structure that can define common sense? Waking up at 4 p.m. is not common sense. Is that a true statement? Is that a false statement? And maybe to also go back, you said correlations in the world might be common sense, but then it might be good common sense and bad common sense. And I'm very lost on how to define it, how to think of a framework to put common sense in, if that makes sense.
I don't think it has a precise definition, but I think it reflects the fact that there's a whole bunch of stuff that a lot of human beings sort of know about how the world works and how people work and things like that, and something in that space we call common sense. Now, and that reveals the fact both that, well, actually, so-called common sense knowledge is somewhat culture specific because there are different beliefs in different parts of the world as to what time you should have dinner and lots of other things, and it means it's likely to also have in it bad biases and stereotypes unless you're careful as well. But in some sense what we have in mind is when we talk to another person, we expect that they understand a bunch of stuff, that they know how to get on and off a bus or to how to get sort of help in a store or something, and all of that stuff's common sense.
I think this question is spot on because, I don't know what's the boundary where you define common sense or your specific, world knowledge. It's a very fuzzy line. You can think about maybe what will come out one day, some kind of a more empirical definition. I learned this chunk of common sense, this hammer of common sense, and I'm going to bang on all possible tasks with the same block of parameters or knowledge base, and it's going to improve everything. So then you will say, well, it's common for all these tasks. It's all common sense. But where to put the boundaries is actually not very clear. And I think, and I might be wrong here, but there was a discussion in Vigil in Europe this year that was about similar lines. And I think there was a cognitive scientist or a psychologist there, and she was saying that for them common sense is actually a much more tight set of skills. So it's very, very small and compact, where it seems like at least the way we define common sense now with NLP is actually extremely broad. So I think there is a very, I agree that there is a strong definition problem here, boundaries.
Yeah, I think common sense is something that's very obvious to us just because we have been in this world for a long time, and it's not so obvious for a machine because it hasn't been exposed to these things. How should we define it is that these are some situations that are plausible and some situations could never happen in the real world. So maybe that could be somehow in the knowledge base in some sense, and generalizations of these situations that could not happen. So it's more about what could not happen as opposed to what could happen, because those are the cases that we know that couldn't occur, but the machine doesn't. And with one simple rule, you might actually rule out a huge space of different possibilities, right? I'm not sure how exactly the data structure you would use to do this, but maybe some sort of a graph structure with some generalization of those nodes. I don't know. Classical, yeah.
Any other questions?
Thank you, great talks. So I think during this talk we hear a lot about like reasoning and like operating on sort of like higher level concepts, and not only just from like raw features and that kind of stuff. But reasoning will have to operate on some like higher level concepts, and from what I can think of, there are like two ways of getting those concepts. One is from annotation, and one is from agents interacting with the real world. And what do you think would be sort of the way to go? Like, obviously, if everything can be learned and composition from the agent itself to a higher like conceptual space, that would be great. But how viable is that? How far are we from really getting that? Or maybe from annotation itself already is can account for a really large percentage of that. And also, like, it's no way for us to enumerate all possible concepts, and how do we really define or get those kind of ontology?
I don't know, like I think something like physics is not something that you need to label. That's something that you can just learn by interacting with the world. Certain things like naming objects, and attributes, or maybe more complicated things probably needs labeling, the same as your parents taught you some stuff, right? And you know, why not teach a machine? Why let it just discover in some unsupervised way? So some things should not be labeled because they're just very simple observations that you could take. But some things I think you need to label, like math, right? If you didn't go to school, there's no way you, or maybe, but I wouldn't be able to do math, right? So there is stuff to be labeled just because it makes everything much easier.
So I can give like so I would distinguish between the labeling, the way we do it now for machine learning, and the way my teacher labeled the math equations for me. Even my parents labeled the mugs and plates. So I don't know. I think it seems very different type of learning. So I would say if you want high performance and if you want to get something done in the foreseeable future, probably annotation is just going to win. But I've never been a realist, so aesthetically, I would really like, you know, to kind of like throw agents out to the world, let them interact with humans, let them try things, maybe even run into the red light once or twice, because, you know, buy any robot tomorrow, and learn by this, because it's aesthetically, and thinking about learning, it's much more pleasing and seems to be closer to the human experience. But I do distinguish between definitely like the more curriculum directed learning is the kind of learning for certain things that we will need, and that's happened in our experience.
Any other questions?
So it seems there's a lot of talk about learning a little bit with less data, and I guess the question I have is, all of these ideas seem to rely on abstractions that there's some evidence to say humans have priors for. Where do we get those priors? Because yes, a baby learns with very little data, but it has some ideas about objects, about how things are going together, about the fact that it cares about its mother. We don't get those. How do we understand the kind of priors that humans have and they impose when they understand these concepts?
But we do have priors even now, right? Like even CNNs are a prior to a certain degree. I mean, it's sacrilegious, but they are. They are very specific. This kind of like filter that we are running and kind of like striding across an image in a very spatial or informed way. So,
but when we talk about the real world, like there's the prior of gravity that vision never gets access to, but we get access to and help us understand why objects reflect in a scene a certain way.
Anybody wanted to answer?
my random thoughts. Yeah, so, I mean, clearly, in some sense, for some things that humans have these sort of built-in priors. So, you know, loving your parents, I think, is a built-in prior. But there are a lot of other things that don't seem to be built-in priors and that kids learn from observing the world, right? So, like, little kids develop notions of object permanence, right? That seems to be very clearly something that they're not born with, that they have to sort of have interacted with the world for a few months before they realize that objects don't just appear and disappear randomly, and that they should know that something's going on when an object has gone out of sight. So it seems like a lot of this stuff is just learned interacting with the world. And so that goes to Yoav's answer of saying, gee, we should have agents interacting with the world. And so this leads into the area of self-supervised learning, of how you can be sort of doing stuff in the world and sort of making your own prediction tasks and learning from them. And I think that's actually a great direction for things to head. I mean, connecting back to the previous question, I mean, I think, you know, in the moment we've sort of been in this phase of the way to make progress seems to be to create ever bigger supervised data sets. So we've been creating ever bigger supervised data sets. But I kind of think a decade from now, people are going to look back and say, oh, those people around 2015 to 20, boy, were they crazy. The only way they thought they could make progress is going from 1 million sized data sets to 10 million sized data sets and then 100 million sized data sets. It doesn't really seem like it's a good way to be doing what we want to have happening.
I guess we are putting priors, right? Like you said, when you're designing a model for some task, you actually design it in a way that it's intuitively clear to you what it should be doing. So maybe the model, like the data set doesn't have intuition about gravity, but you're going to design your network such that maybe it could learn something like that, or you're going to impose it somehow. Like if, for example, you want to solve autonomous driving, you're just not going to throw one CNN at it, right? You're going to design it in a way that's going to have all these module solving things that you think are important. So you're kind of the prior designer here, right? The same as some things that you mentioned for humans look like they're built in. That might be a, you know, something evolved through evolution, right? Yeah, so that's my take.
Thank you. So just going back to having vision models that can also interact with an environment, we found that it was extremely difficult. We did experiments with RL, basically, an agent that took as input an image of different frames and then would output an action. And it was a very, very simple task. It was the agent was just a block, and we trained it to jump over another block. So it only had the actions of moving left or right and then jumping. And what we saw is that if you moved the big block just a little bit, the agent was completely lost. It didn't know how to perform the task anymore. And that was because it was extremely difficult to get the agent to learn the object of this block and to just learn this abstraction. Because what the CNN ended up doing was just looking at the entire image and building its representation based on all the pixels and not focusing on just the feature that really matters, which is what is the distance between your agent and the block, so you know when to jump. And so what my colleagues ended up doing was to do data augmentation. They just kind of jiggled the image around until they had enough examples for the agent to understand that the only feature that mattered in this case was the distance from itself to the big block. And that's how it learned the concept of the object in this case. And I think in general, when you look at the experiments in computer vision and RL, it's really, really difficult to have object-based representations, but it's very critical for generalization, because if you change something in your image, your agent is lost, then it doesn't know what to do anymore. So there's quite a bit of work in this space right now. I think it's very promising, and I think it's definitely something that we need to do better if we want to generalize better.
So we can take one last question, if anybody has one.
Okay.
Thanks. So since the theme of this panel is future directions, we've heard a lot about how really like there are a lot of steps in the VQA, like answering VQA questions correctly. There's a lot of things that you need to do right. But I was wondering if you had to pick one aspect of the VQA problem, what would be the one thing that you'd like to see improved most? And I'm intentionally trying to be a bit controversial here. So I just want you to pick one. So I would appreciate if I could hear that from you. What would you most like to see improved in the next year before we come back to CVPR again?
Okay, so I don't know that I have a. Oops. I'm not muted now? Yeah. This is so confusing. Okay. Yeah, so I guess one thing that I've been thinking a lot about, and we had the opening question was talking about that image of a person with a mustache, or like what is the mustache made of, right, with the banana? So I think one thing that kind of bothers me a lot when I look at these holistic measures like accuracy on VQA is you don't know why your model is coming up with a certain answer. So it's one reason why these diagnostic data sets are so nice, because maybe we can use these diagnostic data sets to probe, how our model is understanding the world. But I think focusing not just on, beating the benchmark number, but making sure that our model is actually doing something robust and will generalize well, and either coming up with good metrics for that or coming up, showing lots of qualitative examples at least is really important. So that's something that I would like to see people do more and think about more.
Yes, so in my presentation, what I talked about is really kind of along these lines, kind of let's take a step back and really look at what our models are doing and what they are learning. So that helps with interpretability, and that helps with knowing what to work on next, right? So I think there's definitely more work to be done in this area of just kind of digging into the models and looking into what they really learn. And then another thing is along the lines of what Sanya presented that I really like is the human in the loop idea. How can we continue training our models with the help of human beings? Because most of the time when you train on a fixed data set, you have some accuracy that's good but not perfect. So how do you continue training? How do you incorporate human feedback? What's the most efficient way to have humans and machine work together? In a sense, so that the machine improves itself over time and yeah, it gets better and better at answering questions. I think, yeah, those are the kind of the two areas that I'm really excited about.
Well, I mean, beyond the directions I talked about, so I agree with Laila. So this notion of like interaction and what we can get from interaction, either starting from scratch or either using it for fine-tuning or either just like learning continuously and just stop distinguishing between test and train completely. It has tons of open problems, and it's really an interesting direction to explore in the next few years. I don't want to commit anything for the next year though, because I think you can come back next year and kind of like pin me down. So that's too much for me.
Yeah, same here. I'm just going to continue this thread. I think everyone is training on these closed data sets. You train your VQA model here, you show some results on a little bit of a held out test set. But then that's it, right? Like if I send this robot to a real world and it's going to make mistakes, it's just going to keep making mistakes. So unless you make it interactive, there's no way to continuously improve, right? So I think the interaction part is really crucial. And to this point, I think it needs to be more than just the machine providing an answer to the question. So just saying cat is not useful, right? Yes, I can give feedback, oh, this is not a cat, it's a dog. But I want to understand the reasoning process. Why did it say the cat? Because maybe it was a tiny mistake in the reasoning process that I could just pinpoint, and maybe that would help a lot of other examples in this case as well. So interaction and interpretability in this sense.
So I guess there were some answers in my talk about, richer compositional reasoning and more interesting scenes. But there's something different that's just very simple, which might be interesting, is maybe it'd be a good idea to start penalizing systems when they get answers wrong. That would be a very effective way of trying to encourage people to pay attention to their confidence in whether they actually think they know the answer or not.
Okay, so this concludes our panel discussion. Let's thank all the panel members for the insightful comments.